All right, welcome back. We are back at it with this Marshall JVM 210H. Actually, I've never played one of these things, but I've heard they're pretty cool. Customer says this one's having some issues. They actually already swapped out the output transformer after, for some reason, suspecting that was an issue. And now it's maybe got no sound. Yeah, so we're going to open it up, confirm that the output transformer was installed correctly, and then take a look from there, see what's going on. Hopefully it's something quick, but we'll see. Let's open it up. Checking out the back of the amp real quick. Man, this thing's got a lot going on. Series parallel effects loop. Serial loop. And then, so yeah, is that 2 effects loops? Got a line out, got MIDI, got a foot switch, some outputs. Cool. Looks complicated. Let's see just how, oh, and look at that. Oh no, okay. There's more preamp tubes hide. False alarm. I thought there was only one preamp tube. Okay, we'll get this thing opened up to see what's actually going on. Okay, so I went ahead and tested all the tubes, all the preamp tubes. Seem, towards end of life, but still good. This one that I've marked came up as pretty gassy, which means it may have a vacuum leak. Although the customer said there was no sound. There was crackling and popping, and then eventually was no sound. It looks like the output transformer is installed correctly from when I flipped it over. And it is the correct type, TXOP0029. So I'm not too concerned about that being the issue. And I am going to test they gave me the original one as well to test. So I'm going to test that just to confirm. I'm suspecting maybe a resistor in the signal path has failed or something. Although if there's no sound, I would suspect that multiple tubes had failed. Let's flip it over and take a look. Okay, so this is an absolute monster of an amp. We have a control board down here for what I assume is for the MIDI switching. There's a DSP board there. Digital signal processing. Got some pretty large ICs for handling who knows what. Probably some of the channel switching or some of the MIDI would be my best guess. I think the signal path on this guy is mostly, if not all, analog. So any of the, kind of out of the norm from what we typically look at circuitry is just going to be there for switching or for things like that. That's interesting. We actually even have a crystal oscillator there for some kind of part of the circuit. Oh, again, that's probably for the MIDI communication. Not bad. It's just different paths. Not the kind of thing I typically recommend for people to get just because when things go wrong, there's not a lot of people that want to work on this sort of stuff. Let's see if we can get this somewhere we can see. I'm going to go ahead and measure some of these resistors, see what's going on. Let's make sure there's no voltage on the amp. There shouldn't be, but just because... Let's see, where are our tube sockets going to be? Okay, nothing there. And then are the power tube sockets? Let's see, are they recessed? There must be a daughter board below this for the power tubes, which is fun. So you'd have to remove this whole board just to access, or no, wait, let's see. These must be the power tubes there. Yeah, sorry, here's our preamp tubes. So it looks like one main board and then a front panel control board here. But let's measure our... Let's make sure our screen resistors are good. 1K. That would help indicate If a tube has blown in a catastrophic way, these are the kind of checks you can do on any amp without a schematic. It's a 1 ohm. Is that what that's supposed to be? Yeah, 1.1 ohm. These are probably for bias purposes. These are the bias controls for each side. This guy is also probably for some kind of bias circuit. You can probably just measure the voltage between each of these sides so that you don't have to hook up an actual bias meter. Okay, nothing standing out there. Over here, just make sure there's... These must be resistors that are in the power supply path. Dropping down different nodes. Nothing looks out of place. The caps aren't bulging or anything. That guy's also good, 470. Okay, that's about all we can do without... I guess we can check the fuses here. Oh, we got a blown fuse. Okay, and that's FS6, which I'm going to guess... Well, let's go ahead and take a look at the schematic and see what FS6 does. Okay, so that fuse on the schematic is listed as going to the anodes, which, man, that sure would be a problem for cutting out some sound. A couple more resistors to check while we're here. Oh, we must be in parallel with the cap. Yep. Anytime you get a negative resistance... Now, important to note, resistance checks can only occur on a powered down circuit. So if you read a negative resistance, you either are across a capacitor and are allowing the cap to discharge through your meter, or you have a powered circuit. Okay, let's pull this fuse and see if we have a replacement for it. Then we'll power up on the current limiter and see what happens. I'm going to guess, my best guess at this point is that one power tube was failing, took out the fuse, but that might be it. So if we're lucky, it's just a tube. This amp belongs to a young local shredder, so would be pretty stoked to get him back on the road as cheap as possible. Okay, going to power down here and see what's going on. All right, I was able to find a 1 amp fuse. There was a 2 amp fuse in there, but the circuit board calls for a 1 amp, and so does the schematic. So not sure if somebody traded that out for the wrong value or what's going on there. But replace it with 1 amp. I luckily had one more of those left. We're going to throw this thing on the current limiter and fire it up. Keep an eye on things. There's a chance this amp is not going to behave as it should on the current limiter because the voltage might drop too low for some of the digital circuitry, which is an argument for powering things up on a variac. However, I want to just do an initial power up to make sure things are good. And then we're not going to blow that fuse or something again if that tube is bad. So let's see what happens here. Okay. Power is coming on. Bulb is staying pretty bright, slowly dimming. Some relays are clicking into place. I see some front panel lights coming on. Let's see if we have any signal coming through. Plug something into the input. I'm just going to plug a cable in and see if touching my thumb to it does anything. Once we come out of standby here, make sure our volumes are not all at 10, which they currently are. And master, pretty low. Okay, we are hooked up to the attenuator. No signal, and it seems like our channels are stuck in place. So that could be a sign that this thing wants more power than the current limiter is able to allow. Let's check some voltages real quick, just before we get too crazy. Make sure we have bias and things like that at our power tubes. I believe this is the one that was problematic. It's one of these two middle guys. Bias is a little hotter on that side. Negative 16 there. Negative 19 there. Yeah. Those two on the outside. Well, that's interesting. These two have the same bias and these two have the same bias. But normally, I wonder if the bias is split. Must be split between those two. Okay, well, that's interesting. Let's see if we can adjust those to be a little closer to each other. Just because. So that's negative 19. This guy's negative 16. And we'll do a proper bias on these guys, but may as well make this more conservative. Start with a colder bias. Just make sure things are happy when we do power up. Okay, that's a little closer. Yeah, let's try. I guess let's try a full power up since nothing's going too crazy. I don't think we have a short circuit. Let's see what happens there. Okay, and I'm just gonna hover over the power button here in case something pops. But let's see what we get. Relays clicked on, sounded happier that time. You can actually switch them on and off. No sound. Very faint sound coming through. Make sure our preamp tubes all have voltage. Sorry, the voltmeter's off screen. This chassis is pretty big. It's a little hard to fit everything on there. Voltage all around. 440 at the plates. On the power tubes. It's interesting, there's these wires going across. Those don't look like they would be stock. Bias is negative 31 for these two and negative 36 for those two, which is a little off. Kind of interesting. Let's see. I'm going to go ahead and power down. Might need to power amp insert. Let's maybe make sure that we get signal out of the effects loop. I'm wondering if something, since this does have a serial effect or a serial effects loop, which means it's in series, if something's getting jammed up there. Tubes are pretty toasty, so we know they're working. Yeah, let's maybe plug our guitar into the return here. See what we get. Oh, well, I need to plug the amp back into the wall. Okay, so no sound coming through at all. So there is something going on the power amp side, blocking all signal. So I can see why they suspected the output transformer. However, there's almost always a simpler solution, and it did seem like it should be okay. Might test one of these other outputs. Now let's maybe verify real quick that our let's see. Let's make sure we're powered down. Let's get in there. I should probably pull these other fuses to make sure another one's not blown and I wasn't just measuring across whatever it is connecting. I'll do that real quick. All right, so we're back in it with the, this is the JVM 210H. Reminding myself because it's been a couple days since I started this, but yeah, things are working now. This one had a couple problems that turned out to, I think, be related. But it started with me finding that the fuse was blown for the heaters, this FS6 down here. So I replaced that guy, had a 1 amp fuse in there, or it had a 2 amp in there, but I replaced with the 1 amp. That's what it should be. Now, there are on these amps 2 different versions. There are ones that have fuses here in this area that are for the heaters. This is a later version, which I think means it's post 2007 or something like that is what I saw online. And that means they basically replaced or, removed those fuses that were in place for the heaters and replaced them with a straight connection because there were a lot of nuisance faults, which means it was those fuses were blowing. People would have to take their amp in to get service because they didn't know it was wrong. Turns out that it was just the fuses that were bad, or that had failed because of a spike in the heater voltage. So those have, in these later versions, been replaced with just nothing there. But this fuse that blew goes to the high tension or the plate voltages. It feeds into the plate voltages. And that had blown, which then led me to suspect or to think that a power tube had failed. I tested all the power tubes. There was one that was suspicious, and I apologize, a lot of this happened off camera, and was getting no sound out of the amp like at all, which usually means there's a problem with the signal path. A single power tube blowing would not necessarily do that, although this amp has enough going on. I don't know if there's some kind of protection circuit to keep sound from coming out. Even with the failed tube, usually if only one side of the push-pull, and this is a 100-watt amp, so one tube going out would still have half conduction on one of the alternation sides, would just produce really ugly distortion, and it wouldn't sound good in like an older Marshall or even an older Fender or something like that. But yeah, again, this one was totally dead silent. So, got some new tubes in there. Should be good, right? Voltages all check out. Everything seems good. I'm still getting nothing until I go to plug, and this whole time I'm testing by having my 16 ohm output from the back of the amp here go to my Fryette Power Station 2, which is set for 16 ohms, which then goes into an 8 ohm speaker cap. So things are to the point where I'm starting to suspect my power station is having an issue. So I plug straight into my 8 ohm speaker cap using a different speaker output on the back that's for 8 ohms. Can you see where this is going? Everything's totally fine. So then I start backtracking, replacing all the tubes. I'd put in a whole new set of power and preamp tubes. I start replacing those one by one with the original tubes that were in there. All the preamp tubes that were in this amp originally are good. Get the power tubes back in, sound cuts out. Okay, so I know it needs new power tubes for sure. Plug back in to the attenuator, 16 ohm tap, no sound. Turns out we have a bad jack. This jack right here has failed mechanically to the point that I have to hold the speaker cable to one side in order to get any sound out of it. So what I think happened was jack failed, which caused tubes to work harder than they should because they saw a no load output. Luckily, the output transformer did not fail, but instead what happened was the tube failed to the point that it catastrophically took out the high tension fuse. And then we were left with a situation where we had bad power tubes, blown fuse, bad speaker jack. Now, unfortunately, this is a good and bad situation. The speaker jack that's in there is not one I keep on stock because it is a PC mount. I'll pull the camera and show you a closer look. But it's in line with the jack. So if the jack were plugging in this way, there's PC pins that go straight out. There's not enough room to get a normal like Switchcraft style or Cliff jack in there that's isolated. And I don't keep those in stock, so I had to order one of those jacks. Luckily, the customer is okay with just having some new tubes in there for now. They're going to bring the amp back to me once that jack gets delivered, and then I will perform that service for the amp. But for now, I'm going to be sending this back with some tape over that output jack so we don't blow tubes again. So that the customer knows not to use that output. They can use, there's 5 speaker outputs on this amp, so they should be fine. They have a cab that can handle it. They can handle the 8 ohm output, I should say. But for now, they're going to get a set of new power tubes, monitoring the bias right now, the compu bias. Going to set these to about 15 watts dissipation per side for a fresh set of EL34s. Using my ceramic non-conductive screwdriver here to do my bias in case I drop this thing. Yeah, and we're sitting about 15.1 watts right now. That's pretty good in the middle of the range. Bias it a little hot, but not so hot that they're going to just blow through tubes. Okay, so this is the JVM 210H. Let's see if we can get some sound out of this thing here before I cut you loose. We're going to be just putting this thing back together once the bias stabilizes. Pretty sure my guitar is very out of tune. Okay, so that's going to be it for this one. As always, thanks for watching, and I'll see you on the next one.